Hello, I'm Mike Rockwood, General Manager of Associated of Los Angeles, where for over 85 years we have supported Southern California schools with the best in electrical supplies from the leading manufacturers. But supplying parts is only one thing our customers rely on us for these days. Another is to provide training on state-of-the-art technologies and products to help them cut costs and reduce energy use, and that's what this video is all about. Title 24, California's energy efficiency standards, have been revised by the CEC with some dramatic changes that go into effect in January. Your school engineers and your school electricians will want to hear about these changes right away so that they can plan for implementation and so that you can begin to achieve the cost savings and the energy savings as soon as possible. Now, many Southern California schools use WattStopper brand lighting control solutions to achieve Title 24 compliance. WattStopper's Regional Vice President, Charles Nufke, is an expert on Title 24, and recently he met with the electrical supervisors at the LA Unified School District to explain the upcoming changes. We thought you and your team would enjoy hearing that message as well, so we recorded it for you and provide it here. We'd be pleased to arrange a similar presentation at your facility. Contact me at Associated of Los Angeles at the number on your screen to schedule it. Thank you. And from all of us at Associated of Los Angeles and WattStopper, we look forward to serving you soon.
Thank you everybody for letting us come in and present to you. Before I start, how many of you have gotten any idea of what the changes are in the next generation Title 24? Has anybody been out talking to you yet? Okay, so usually I refer to this as fresh meat because there are so many changes that are going to happen, and quite honestly, don't feel bad. I go out and I do presentations to the electrical engineering community, I do it to the electrical contracting community, I do it to distributors, I do it basically to anybody that'll let me in the door. And on almost any given presentation, less than about 15% of the people really feel like they understand what's going on with the changes. And they're huge. What I do on every one of the slides is try to make sure if I say something, you can take a look at this and go, there is no way that they put that in the code. This guy is making stuff up. Well, check me on anything I say, because every slide has got the section that I'm pulling it from, and the entire code is now available on the website. So you can go in and see that, see what it is, see whether or not I'm reading it wrong, whether I've interpreted it wrong, and let me know. That's why I've got my email address on the front page. If it's something brand new, like a whole new section, like we talk about, oh, well, you're familiar with interior lighting controls, but are you aware that there's new power requirements? The whole new power section is there, and I try to remind myself and anybody that's looking at this that that's going on. I also maybe indicate something that's new, or I might just make it underline or red, and that basically says the thing was there before, but they made a minor change to it. So, and before we begin, this is the message that I try to bring to you all is, don't shoot the messenger. I always try to bring what I think is an ombudsman role to that, which is based on whatever proposals are there, what does this really mean for the people that I've worked with over the years, the electrical engineers, the contractors, and particularly the facility folks? What is this going to mean to them? And is this going to impact them in a way that's going to be particularly harmful? Or I don't even understand why we're moving forward on this. So I, however, don't get to write the code. So they take all these different meeting notes, they put them in front of the staff scientist at the CEC, they go through, and they're the ones that then weed through and figure out, well, what should be in the code and not. And it was a session actually up in Sacramento once that, I had gone through the whole presentation and I explained it, I thought, very well. And somebody raises their hand, oh, gentleman in the front, question. And he goes, yeah, I got a question. When are you going to stop doing all this stuff to us? And that's why I put the slide in the presentation. No, it's not me putting you in there. It's just I want to make sure that you're aware of what's going on. So there's always been this worry about sustainability and the green movement, the idea of making sure that there's enough energy out there. It gets kind of a funny relationship that some people have with the utilities, because the utilities actually want to pay you money to try to use less of their product, because there are huge rewards for them if they can do that. But there's also one other thing that's happening, which is a lot of good ideas, things like the LEED process. How many of you have got LEED schools that you've been working under, right? So there's a lot of really good things in LEED, but LEED is, for a lot of places, completely voluntary. If you take some of those requirements and make them in the energy code, every building in California that gets built has to follow whatever it is. And so you'll start seeing some of these ideas start up in the code, more so and more so. And the good news for us in California is that California has actually been very steady for about the last 30 years. The green line represents the per capita energy use in California. The issue in California isn't that we're all using more energy, despite the fact that we all have probably TVs and Wiis and Xboxes and all the other electric stuff that you have in home now that you didn't have 30 years ago. The California issue is we just have more and more people, which is driving it up. But imagine how bad it would be, in 2000, 2001, when we had the brownouts, if California was like the average for the entire rest of the country, that basically had doubled in their energy usage over the past 30 years. People make fun of us, but the fact is we've been doing the right thing, but both California and the rest of the country are now being challenged to try to get to zero net energy buildings. So by 2020, residential buildings in California are supposed to be zero net energy. By 2030, commercial buildings are supposed to be zero net energy, meaning they don't use any more energy in all their processes than they can actually manufacture on their own, either on-site or off-site. Well, that's huge. I mean, with everything we're doing, imagine how much energy is being used just in this building to heat and light it, and imagine trying to cover all that with energy usage. The good news for us, though, is this is not just a California effort. So this is actually a kind of a flow chart for where the federal codes are going, which is ASHRAE, that they've been putting in code requirements, but they've got plans for the next 20 years, basically, to try to continue down to that same zero net energy idea. So, well, what you don't know is there are some codes out there that really it's two sticks and a carrot that really form the basis of the codes. The first stick is, when nobody's in the space, right? You look around in the building, when nobody's in the space, turn the lights off. Okay, so that's the minimum automation level. Make sure when nobody's in the space, the lights go off, because it's really hard to beat a fixture that's completely off for anything else to save energy. But then you wind up with the second tier, which is, okay, what about when there are people in the space? We're all sitting here in the space, right? So what do you do then is you try to bring into account daylighting, you try to go to lower light levels, you try to actually go to higher efficiency fixtures. All those come into play to try to make sure that we lower the energy usage when people are in the space. And then what California does that's kind of unique is that they actually offer incentives and say, if you go beyond all this, we'll actually give you carrots, and you can take a classroom that's using 1,000 watts, you can call it, let's say, 800 watts, and you can take that extra 200 watts and use it someplace else to put more lighting in a place that otherwise you wouldn't be allowed. So if you wanted to get the code, here's the code location. You can go to www.energy.ca.gov/Title24. You get to the first slide. It talks about the upcoming 2013. You click on that link. It brings you to the energy codes. You can download a marked version, and you can download the code. It's only about 250 pages, so it's nothing that you guys probably wouldn't want to read through, in a night or two when you're trying to get to sleep and have no other way of dealing with it, right? So you can download that, and if that wasn't enough fun, you can also download the compliance manual. So the code is the code language that says what it specifically requires. The compliance manual is the interpretations and examples and all that, and that's about 1,467 pages. And the big date is this one, January 1st, 2014. So if somebody goes out for plan check after 2014, January 1st, somebody could turn around and say, you need to be following the new code. So imagine a building that goes out in December for plan check that gets kicked back, and then all of a sudden doesn't get that date, and then somebody turns around and says, oh, by the way, you didn't see all these new requirements, you've got to completely re-engineer the job. So the overview of the code, regulations is a section I typically don't worry too much about. That's where it talks about occupancy permits. Systems and equipment, we'll talk just a little bit about that. Mechanical, as I said, I'm going to stay away from. But lighting controls is really where I live and breathe, and we'll talk a bit more about energy calculations, and this one here is a big change as well. And we're going to skip residential for today. We're just not enough time to do all that. So one of the things I like throwing out is this one. This is kind of an indication of the way the code folks think. Sometimes you can't put something in the code today, even though you really want to. And a perfect example is they'd love to tell you to put photovoltaics on the roofs of all the buildings. Problem is there's not a payback that meets the code requirement of 15 years. So they can't tell you that you have to put the photovoltaics there. What they can do, though, is get you ready for it. And so there is a section here, it's early in the section 110, that says for any new buildings, you've got to have a roof space that's been set aside, that there's no shadow that overlays it, no penetrations from below. So in the future, you can add photovoltaics to that roof. So they're not telling you you have to put the PV on the roof now, but they want to make sure later on, if you decide you want to do it, there's a nice little area set aside on the roof to be able to do that. This is already part of the Cal Green Code. So some of you may have already seen this, but this is now going into the statewide code, so every building's going to have to follow this. And for any of us in the electrical biz, it talks about making sure there's also room set aside over there at the main service panels, because you're going to have all this DC power that you want to bring into the AC grid, and there's going to be a bunch of equipment that's going to require to do that. And the code's saying make sure you got a space that's set aside in the main service area just to be able to add that in. So let's just jump right into lighting controls. These are the different sections that are really the primary ones for the interior lighting controls. If anybody had memorized the section numbers, they actually changed the section numbers. They swapped 2 from the last go around, and they moved everything from what was 131 to 130.1 to give them lots of extra room to be able to add things later on that they might want to put in the code. So the first one is, the first basic idea is called the area control. The area control is really simple. It's the idea that in any given space, somebody in that space should always be able to turn off their lights. Okay? How many times have you been in a space where there hasn't been a switch on the wall? Not that often. And yet it's so important that they thought we better make sure that every space actually has a switch in it. So the code requirement in black is the same as what it was before. Make sure there's a space device. Make sure that somebody can always turn the lights on and off. You can throw whatever automatic controls in that you want, but people always have to be able to go to a lower off level if they want to. What they have done is added, or actually taken one thing out. It used to be that if you wanted to meet this, you had to have a switch on the wall or an occupancy sensor. They said, well, we don't care if you've even got an occupancy sensor anymore. You still have to have a switch on the wall. So in a bathroom, there has to be a switch. They did say and realize that that might be a problem in some areas. So they say if you've got a 2 or more stall bathroom, it can be a key switch. And actually, they said captive key switch, but they really meant key switch, so that somebody doesn't go in and turn off the lights during the day when people are in the stalls. Here's one that's kind of interesting. You could have schools where you've got dimming fixtures by the window for the daylighting control, but somebody says, well, I don't want to put a dimmer on the wall. That's too difficult to understand. I'll just put a switch on the wall. The code now says if you've got dimming fixtures, it's got to be a dimmer on the wall to control those fixtures. And you'll see this actually in the next slide after this one. They also make sure if you're doing something like retail, if you've got different types of lighting, let's say we've got the general lights, but we also had wall sconces or can lights. They also want to make sure that there's a separate switch for each one of those lighting sources. This is really probably the biggest change in the code and the one that most people are shook up by. So in California has been the land of the bi-level lighting for a long time, right? The reason why we have not 1 but 2 switches on the wall is because we want to be able to go not just from 100% to off, that there's got to be some intermediate level. Okay? What is the intermediate level today? Any level that you want between 30 and 70%. Okay? Nice and easy. They're going to change that. If the area is greater than 100 square feet and it's greater than 0.5 watts per square foot, you now have to go to a table. And rather than go through all this other stuff, and I will come back and hit this one, let's get to the table. This is the new requirement for lighting in California. And I guarantee every manufacturer of controls and every manufacturer of lighting is going to be talking about this slide. So let's take a look at the standards that we're used to. Any linear U-bent fluorescent lamp greater than 13 watts. It used to be 100% on, 100% off, and something between 30 and 70%, right? I now have to be able to do full power on and full power off. We already saw that. I also now need, because it's a fluorescent, I have to be able to get to a medium level. Well, there's 50 to 75%. I have to be able to get to a low level, 20 to 40%. But then you get over here to high. For all the fixtures, you've got to be able to get from 100% to 80 to 85%. How are you going to do that? The answer is it's not going to be switches on the wall. In order to do that, what this is really doing is anybody who's using standard fluorescents, it's going to push them into continuous dimming. So all those spaces that were normally just bi-level switched are now going to have continuous dimming. And the key is those numbers that we talked about before. If it's 100 square feet or larger, we have to do it. And if it's 0.5 watts or greater, we have to do it. So what California is really doing is it's making a bet. They view this as so important, dimming fixtures, that it's an enabling technology. Because if you have this, then you can do all this other stuff. You can do manual dimming, you can do daylighting much better than you probably could, you could do demand response. So they're basically saying, we're going to make a bet with the manufacturers that if we give them the entire state of California, because dimming ballasts right now are kind of expensive, right? If I give you the entire state of California and all those dimming ballasts that you'd sell, I certainly hope the price point falls down. And all the calculations that they did that justified this was based on a much lower cost for dimming ballast than is actually available right now in most places, because they really counted on this competition bringing the price down. Now, I'm not sure competition is going to bring the price down quickly between the ballast manufacturers. But here's one. How many of you are looking at LEDs for the schools for general lighting? Okay? If you're doing LEDs, there's no question about it. If you've got general lighting LEDs, they have to be dimmable. There's no question about different levels or anything like that. You've got to have them be dimmable. When they ran the numbers for the code for the payback, they did it based on occupancy of office building. Office building occupied 250 days a year, right? What's the occupancy of a school? Typically, it's about 180 days a year. So they couldn't make the numbers work in a school. So schools actually get a slightly different number. If you're in a classroom, so it's got to be a classroom. It's not just other areas, but it's got to be a classroom. You need to do dimming. You need to follow this requirement if you're above 0.7 watts instead of 0.5 watts. So one of the games for sure is going to be for folks to try to really get to low power wattage is going to be to try to get those classrooms under 0.7, because if they do that, then they don't need to do dimming here, and if they're using LEDs, they don't need to do dimming there. However, the fact is with LEDs, you'll probably get the dimming for free anyway, because there's not that much of a cost differential between an LED that's dimmable and one that's not. So this is a huge change. This is every building in California now having to deal with about half their floor areas is what I figure that'll probably be dimmable fixtures. Compared to right now, what percentage of your buildings have got dimming lighting in them? I mean, you got the conference rooms maybe. That's about it, right? Now all these other spaces are going to have to be dimmable, which means the wiring is going to be more complex, which means the contractors who install it are going to have to spend more time making sure that they really understand how the wire goes in. It means it's going to be a different ballast than you're using before. All this comes into play because California really wants to get to that idea of get the enabling technology of dimming into all these spaces, and now we can take advantage of all these other things that we might want to do. Other types of lighting I won't really go into. They are not nearly as onerous as those guys. Compact fluorescence, things like that, HID, induction, and others, one step still between 50 and 70. But this one here is going to change California in the next 3 years, for sure. Then we get into the shut-off requirements. So this is the section that talks about you got to make sure that something turns off the lights automatically when nobody's in the space. For the most part, it's up to you. Occupancy sensor or time switch or other device to turn the lights off automatically when the space is left open. That's for something like a security system at a retail place. When the guy locks the door at night to lock the store, the lights go off, that's fine. That meets the requirements of the code. So the language in black is what was there before, so let's kind of highlight some of the key ones. There are some areas that before had to be occupancy sensors, and they're now saying, oh, and by the way, there are some areas that are going to have to be partial on-off sensors. There used to be an exemption for corridors. If I had a corridor, I didn't have to do an automatic off. That exemption is no longer there. They took it away. Parking garages had an exemption from automatic off. They took that away as well. Egress lighting, security lighting in a building used to be 0.3 watts per square foot. Pretty high, so you could have a lot of stumble lights that would be on 24 hours a day, never go off. They've reduced that down to a sixth of that. You only have 0.05 watts per square foot to put in security and egress lighting. And somebody actually read the electrical code and figured out that the code mandates having automatic means only in an electrical closet. NEC prohibits that under, I think it's 110.26d. So they added that to the list of things. So what you're doing isn't so much different, but where you're doing it is going to start changing. And then we get into this whole idea of partial on and off sensors. I don't know about you, but I always thought timer switches as being the most logical lighting control device in the world. You turn it on for 30 minutes, and then 30 minutes later, tick, 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 it turns off, right? Somebody really has a problem with timer switches. So it is now listed in the code that you can't use timer switches, countdown timer switches, for interior building spaces. We're going to include this in the code now, make it very clear. Timer switches cannot be used as an automatic off, except server aisles. You get a lot of airflow in server aisles, people hiding behind equipment, so you can do it there, but it can only be 30 minutes or less. And this one here I kind of like, for whatever, single stall bathrooms, you can have a timer switch. But now they're telling you how long you have inside the bathroom. So you only have 10 minutes. So no big literature, no big magazines when you go into the restroom or anything like that. It needs to be short articles, and I'm sure that everybody is glad as I am that now the code is starting to reference bodily functions, right? You know, this, because I'm really scared to think about where they're going to go next on that. But those are the only two places inside buildings that you can use timer switches from now on. The time clock hasn't changed at all. Still, you know, make sure that it goes on at a certain time, goes off at a certain time. If somebody overrides after hours, it's on for no more than 2 hours, except for certain buildings. These are the buildings that in the last code go around, they said specifically, okay, we know we told you you could use anything you wanted to turn off the lights. In these 4 spaces, though, it's got to be an occupancy sensor. So for you guys, classrooms of any size, conference rooms of any size, individual offices is important. Multi-purpose rooms less than 1,000 square feet. All 4 of those spaces. But really, what it means is you can't use a time clock to be your automatic off in a classroom. Okay? It's got to be an occupancy sensor. But this is new. So they take the idea and they say, oh, okay, well, we've said occupancy sensors would be really good in this space. Let's go and have partial on-off sensors. Now, this is a whole new thing. There never had even been a definition of a partial on-off sensor before. So they created a definition for this code. Partial on means when you walk in the room and the lights only go partially on. They don't go 100% on. So it's a sensor that always only goes on to a half level or something like that. Okay? A partial off is what you might have in your stairwells, right? That you've got full lighting when somebody's there, but when somebody leaves, it goes down partially to a mid-level. So it doesn't matter. You're either coming halfway up from the bottom to a half level or down from the top to a half level. So these spaces now need to have partial on-off sensors, and they have to go completely off at night when the building's vacated. What are the spaces? Warehouse aisles, open areas in warehouses. You've now got a requirement that in warehouse aisles, you walk into the aisle, the lights only go partially on, or if you want to, you can have it so that they're partially on all day long, and then when you walk into it, they go full on. Either of those meet the code, but at night, the warehouse has got to go completely off. Library stack aisles, same thing. If it's a longer stack than 10 feet or 20 feet, depending on whether it is open at one end or both, you've got to have high-low type lighting for that aisle as well. So that somebody could have it lit so it's always half level, and then when they walk into the stacks, the light goes full on. And then here's where it gets kind of interesting. Corridors and stairwells, this is a requirement for that same high-low with an automatic off. So they're saying corridors now, you have to have an automatic off at night. Now, you can still have the egress lighting on, but this is a huge change because that before corridors were completely exempt from the code. And stairwells, whereas I can kind of understand corridors wanting to turn those off, except for the egress light, I have a real hard time understanding the stairwells. Stairwells are listed as well. So at night, when nobody's in the building, the stairwells are supposed to go off, except for the 0.05 watts that they are allowed for egress lighting and security lighting. All right. That same idea of partial on and off they have for other spaces, except this is where there's no automatic off. So partial on off for corridors and hotel, motel, multi-dwelling units. There, you never have to go fully off, but you always have to go so that when somebody's in the space, it's lit halfway. When they walk in the space, it goes up to full, and when they leave the area, it goes back to a half level. So we have that here. And then here for parking garages used to be completely exempt from automatic off. So they're saying, okay, we're not going to tell you that you have to turn these off completely, right? This doesn't have an automatic off at the end of the day. But we want them set up so that they're high-low during the day, high-low during the night. And by the way, we also want to make sure that you don't have it so when you walk in one area of the garage, the whole garage goes on. Basically, if I walk into an area, I can't light more than 500 watts of lighting in the garage. We'll talk a little bit about daylighting. So in daylighting, we've got the 3 basic different lighting zones. The first one is if I've got a skylight, I draw the daylit area around the skylight, and the rules for the engineer is that They figure out 70% the floor to ceiling height on each side. That gives you your daylit zone. There used to be a rule that said if you had a window and it overlapped with its daylight zone, with the skylight zone, the window zone would win. They've changed that and said now the skylight zone wins if there's any overlap. They also tried to make it clear that if I've got any racking in a warehouse or anything like that, whether or not the rack blocks the light. And they said if the rack is greater than 50% the floor to ceiling height, then it blocks the skylight. Then we've got the primary daylit zone. So it used to be that the depth of it was the header height, which we're still using. So 9 foot deep in, right? The width of it, though, is now the width of the window plus, it used to be 2 feet on either side. It's now half the header height. So it's actually 4.5 feet on either side of all those windows. Then I've also got secondary daylit zone, which is the next header height in, so the next 9 feet in this room, plus the same width as before. Right? So I've got a primary side lit and I've got a secondary side lit zone in this room. Okay? So here's the new hierarchy of the way the zones overlay. Primary side lit by the window, skylight, wherever it overlaps, it wins, and then the secondary side lit if there's all three of those in a space. So now here's the rule. It used to be that they'd say, okay, well, if you had a daylighting zone, that you needed to be able to take the lights in the daylit zone and reduce it without touching the rest of the room. Okay? They got rid of that whole idea. The reason is because they've now mandated in the primary side lit and any skylit zone that you have to have automatic daylighting controls. So daylighting controls are going to be all over the place in California. Most engineers use what's called the prescriptive method. And the code says in the prescriptive method section, if you use this method, you also have to have automatic daylighting controls for the secondary side lit zone. So this room is a perfect example that you'd have daylighting controls to be able to lower that one down based on whether or not the shades were open, and this one down a little less. So there's some requirements about it. They say, well, the daylighting controls have got to lower it based on the table that we saw, the multi-level. Controlled lighting in daylight shall not be less than what the electric light is, so that we make sure. There's a rule requirement about percentages that basically says you never have to turn inside a building the zone completely off. You just need to go to a lower level. Okay? So there are a lot of people that don't like turning the lights completely off with the daylit zone, because if you walk into a classroom and somebody sees the lights are off, the assumption isn't that there's a daylighting sensor there. The assumption is the lights don't work, right? So inside a building, you get a lot of people say, no, I like the lights to go down low, but I don't want them going full off because then I might not be, I might get a complaint about it. Now, so here's the exemptions. Okay, so you got to have automatic controls. The exemption before used to be you didn't have to do it if the side lit zone was 2,500 square feet. Okay, they changed that, and the new exemption now is if your skylit or primary side lit zones are greater than 120 watts. So in this room, in addition to having the automatic off and the switch on the wall, and in this room, based on the lighting power density isn't low, so you'd also have to have dimming control. You'd also need a photocell to control both of these fixture rows separately. It's a lot of controls. Okay? So there's also a requirement if you had any parking garages that they want to make sure there's also daylighting in parking garages. So you've now got that high-low system in the garage, plus you've also got to make sure you have photocells to turn off the lights automatically if it's greater than 36 square feet of windows or openings. Here it's a little different. In fact, what they say is that based on the levels that you got to hit, this does say if there is enough daylight, you have to turn the lights completely off. So garages used to be, you didn't have to do anything in there, right? Now you've got to do the high-low, which typically means you're going to have occupancy sensors to do that, and you've also got to have daylighting controls in the garages as well. Then if you've got a building greater than 10,000 square feet, this is a completely different section than was before. It used to just be retail. Now this is for all buildings greater than 10,000 square feet. You've got to be able to take a signal from somebody like a utility and be able to drop 15% of the lighting total power of the building. So the engineer goes through and figures out total lighting load for the building, figures out a zone size that represents 15%, and then figures out how that, based on a contact closure or a signal coming in from a utility, that they're going to go to a lower level. And if you thought you'd just turn off all the closets, you can't do that. They say it's only habitable spaces. The give back is that anything that's less than 0.5 watts don't count toward the total power. If you get a space that's below 0.5, then you don't have to include that. So if my entire building is less than 0.5 watts per square foot, I don't have to worry about this at all. If I'm under 10,000 square feet, I don't have to worry about this at all. Outdoor lighting, they touched as well. There's a thing that's always been there for a long time that says if you're using incandescents outside that are greater than 100 watts, make sure they're on a motion detector. They've changed a whole section of the code, though, that talks about glare. So you may hear somebody actually refer to what's called the bug light standard. Bug light stands for backlight, uplight, and glare. And it's a way of saying how much light should come out of all these different sections. So here's a pole. I've got the light that's coming out on the front. I've got the backlight, and I've got uplight. So there is now a whole section of the code that talks about how much light I'm allowed to have on the uplight. And for glare, that's basically the light that doesn't go down. It's the light that goes either 60 to 80 or 80 to 90. You've got a ball field area and somebody's putting lights in. The question is whether or not the houses in the area are going to get any glare. This is what they're going to use to determine whether or not the poles that you use are putting any glare in there. And there's a whole table that talks to the different lighting zones in California. So zone 3 is like a urban, zone 2 is a rural. This is kind of a super urban, real downtown area, and this is a national park. So there's each one of these talks about the different slices that was in here. For the glare, backlight very high, backlight high, forward very high, forward high. So forward very high, backlight very high, forward high, backlight high. So this is telling a manufacturer, in order to be able to sell a pole that goes in this portion of California, it can't have more light pollution than what's specified here. So this is something that got put together actually by the International Dark Sky and IES groups. So this is really attacking lighting pollution. By getting it into the energy code, they've covered the entire state of California and all buildings in it for the next 3 years at the very least. For controls for exterior, the requirements are make sure they go off automatically by a photocell or time switch. There's this new requirement there that says, oh, by the way, all exterior lights, even if you have it on a photocell, it's got to be able to be turned off by an automatic scheduling system. So this means even if you've got photocell controlled pole lights, my reading on this is you still need to have those circuits going through a panel or something to turn them off and schedule them off separately from other loads. This one I got to check because this one I don't really understand why they added that. There's also this idea, that whole high-low thing that we were talking about inside for corridors. They've got this now, the same thing for exterior. If you've got a pole or any lighting fixture that's greater than 24 feet above the ground, there has to be an occupancy sensor or something to be able to go to a low level when nobody's in there. So you got all the lights that are in the parking lot are at a low level. Somebody walking into their car, the lights go full high. When they leave the area, the lights go back low. They don't want the whole parking lot coming on again, so there's a limit to 1,500 watts, so I can't have it. I have to basically, I can set it up so the sensors in a 1,500 watt section talk to each other. And there are limits, so if somebody goes, well, what about the little bollard lights or anything like that? Well, if it's less than 30 watts non-pole, you don't have to do it. If it's less than 75 watts of a pole light, you don't have to do it. But that's still an awful lot of controls now where you're going to have sensors in the fixtures for exterior areas. Then for specific areas of exterior lighting, outdoor sales frontage areas, you got to have that part night device. So this is something that'll turn off the lights for part of the night. So I turn them on at dusk, but I turn them off at 11 o'clock. I have to have that for these areas or motion detectors. And for facade, ornamental, hardscape, and dining, I have to either have a motion detector or something that turns off by a schedule for part of the night. So all that stuff is pretty significant adder. Before, the exterior thing was we want 2 zones of exterior lighting, the zone that goes on at dusk, off at dawn, and the zone that goes on at dusk and go off at 11 o'clock. Now you've got all that, but you also have this mandatory motion sensor requirement if they're greater than 75 watts of pole lighting or greater than 30 watts of non-pole. We move on to a completely different section, section 130.4. This talks about certification. So this is the idea that the contractor goes out and verifies that the forms that the state requires are filled out, that they're submitted, so everybody gets that. Well, the state's worried about the fact that the contractor who's signing it might have a contractor license but not know anything about lighting control. So you have air balancing before somebody goes into a school, right? There's an air balance test technician that goes through and hits with their funnel and checks the inflow and outflow of all the things. There's now going to be, for lighting controls, this brand new idea, a certified lighting control acceptance test technician. So there's going to be a whole school that electricians will have to go to learn lighting controls. And it's Certified Lighting Control Acceptance Test Technician, CLCATT, cat, so I called it a kitty cat. So there's my little kitty cat dancing away. So this is the curricula that these people have to follow. And this really is not manufacturer. This isn't a rep or anything like that. This is an electrician who's working for the contractor or another electrician that that contractor hires to sign off on all the forms. They've gone form crazy on the last go-around. What was about probably, I don't know, 80 pages of forms is now up to about 240 pages of forms in the manual. And here's the curricula that you have to go through in order to be able to be in order to be a kitty cat, you got to go through all this and learn it. And power is something that's brand new. We've never talked about controls requirements for power, right? It's receptacles. They're on all the time. There's all the power that we deal with. Well, there's now a whole new section that talks specifically about power. It says all buildings have to be enabled to receive an act-on-demand response signal. So this is where they're saying, oh, by the way, you have to be able to act on a demand response signal from the utility from now on. The other big one is this, metering. So metering requirements are based on the size services for the various building that you have. So if it's less than 50 kVA, 50 to 250, 250 to 1,000, or 1,000. And most of these requirements are pretty easy going. I got a smart meter at my home up in PG&E territory. My smart meter will do all this, right? Instantaneous kWh for the building. Historical peak, it'll be able to tell me. I get the little map from PG&E showing my graph for the month. Resettable kWh, okay, that's nice and easy. And kWh for 8 beer. So all this is really easy. This is not. This is where they take that one step further, which is based again on those 4 sizes that we were talking about of services. For smaller services, all you need to know is the total electric load for the building, except break out anything that's for electric vehicles. For other size services, I need to know my lighting loads separately from my plug loads, separately from my EV. For larger size, I need to know my lighting loads by floor, by type or area. You got a 3-story building, you've got to know what the lighting load is for each of those 3 stories. You need to know what the plug load is for each of those 3 stories. If you've got groups of plug loads that exceed 25 kVA in a lab area or something like that, you need to know what that load is separately from everything else. This is going to mandate power monitoring equipment that we've never typically had as a requirement before. And the rationale on it is this, is you want to save energy, is it actually happening? If you're not saving energy, where is the energy being used? And my chart, I only put 3 things on it: lighting, plug load, and charging station. The chart in the code includes HVAC, water pumps, elevators, theatrical, commercial kitchens, and renewable requirements. All those have to be separately monitored. The next thing that's still in the power section, right? A lot of office buildings, you've got the general light has been going lower and lower and lower, so people have been going a lot more in task lighting, right? So task lights are great, but what turns off the task lights? Well, I do usually. When I go home, I turn off my task light. It's nice and easy. Well, the code wants to make sure that the plug that the task lighting is plugged into goes off automatically. See, there's usually a little more of that. There's that look of stunned surprise and slight dismay, that goes along with this. So in these areas, private office, open office, reception lobby, conference room, kitchen, and copy room. So for you guys, notice classrooms is not included on this. But you may have other spaces in the building that are definitely required. So there are now going to be 2 types of receptacles. There's going to be the one that you're all familiar with right now, right? That right there, 24 hours a day, gives you power. That's going to be referred to as an uncontrolled receptacle. Within 6 feet from every uncontrolled receptacle, I have to have one that goes off automatically when the space is vacated. And it's got to be marked. Maybe it'll be green or something like that, so you'll actually know what the difference is. Now, if you want to, by the way, you can do the break-off link thing. So I can just bring a switched circuit and an unswitched circuit to the receptacle and do the break-off link. Otherwise, I'd have to have that one and then a green receptacle within 6 feet from it for the control thing. And the code says, by the way, it's whatever's controlling the lighting in the area is what controls that receptacle. So in spaces where you had to have an occupancy sensor control the lights, like a conference room, it's got to be the occupancy sensor that now not only controls the lights, but also controls the receptacle in the space. Motel hotels have also got this requirement for receptacles. So I'll tell you a little story. So WattStopper makes a wonderful product. It's a little tiny strip tap that's got a little personal occupancy sensor on a telco cord. Just plugs right into there. If you're in the area, part of the strip goes live, the other part is always live. So we were completely set up for this until we got here. Plug-in strips that use occupancy sensors shall not be used to meet the code. Why? Because somebody could unplug it. It's a building code. It's got to be permanent, right? So this has got to be a permanent solution. It can't just be a simple little plug-in strip. And they did make exceptions for things. Okay, you know, if I'm in a kitchen area or something like that, kitchen copy room, you know, I've got a fridge plugged into a receptacle. I don't need to have an uncontrolled receptacle right next to it that I don't plug my fridge into. But this is the way to go after the task lighting, is you make sure these receptacles are there. ASHRAE's had this for 3 years. The national code has actually had plug load as a requirement. But I've got territories that are part of ASHRAE. I never hear about plug load control in any of them. So I think the thinking was if they get it in the California Energy Code, it'll be enforced, and then the rest of the country will start enforcing it as well. There's going to be more skylights, so they changed the code. It used to be only buildings 3 stories or left needed to have skylights if your roof was 15 feet or greater. They've reduced it, so it's any building where I've got a 15-foot or greater roof. The calculations, this is really not mandatory controls. Everything we've talked about so far is just this. Mandatory controls for the inside. For the engineers, they've got to go through and figure out what they're actually using in the building and what they're allowed to use during the different space, and then compare, and hopefully everything complies. There's still, if you're an engineer, a nice little table that you can take advantage of that says, if this is the carrot, basically. If you go beyond what the code requires, we'll let you take an extra energy amount out of the room, and you can use it someplace else. So that's still there. So this is very important, this whole section 140.6 for a lot of people trying to figure out how they're going to do things. For exterior lighting, not so much that's different. Actual lighting versus what you're allowed to use. The one thing is if you were in a municipality that said you had to have a certain minimum level or average level of lighting, they've taken that table out. So the only things you have to figure out what you're allowed to use is how much you're allowed to use in the hardscape, and then certain specialty applications. And they make it very clear. I can take extra lighting I have here, extra energy, and I can move it to an application. I can't, though, if I don't have like drive-in lights, I can't take that energy and move it up here, and that local ordinance is completely gone. So this is the table that talks about some of those specific applications. So the code basically gives you an energy amount that you figure out based on your lighting zone in California, based on how much energy you're allowed to use in the hardscape. And then there are all these specific applications where they say, oh, by the way, if you've got driveway lighting, we'll give you a certain amount of energy for that. If you've got an ATM at the school, we'll give you an amount of energy to light the ATM, but you can't take that energy and use it for anything else. They refer to it kind of as a use it or lose it. You got to use it for that specific application or else it's gone. So there are only a couple things that are left, but this is one that's actually pretty significant. If you think about the utilities, right, and the code folks, this is a very significant departure. This is really moving the code from where it was before. They're trying to take a big giant step. And again, why are they doing that? Because they want to get to that zero net energy by 2030 for commercial buildings. So you got this code. What's the code apply to? New buildings. So great, you've got this new school that gets built, right? And it's brand new, shiny, and it's super energy efficient. And what they're afraid of course, is across the street is somebody's old building that's been there for 40 years, still got T12s in it. They've never gone in and done any retrofits or anything like that, or minor. They've always done just small little retrofits inside of space. So what they're looking for is a way to change the code to allow them to go in and reach into the existing stock of buildings that represents about 95% of the buildings in California, right, and squeeze some of that energy out. This section has been in the code for a while, but the section talks about lighting system alterations and modifications in place. Us in the room, we call this a TI. I want to go in, I got an area, I want to change it out a little bit, I want to do something new to it. This one here, this is like a ballast retrofit. Okay? So the rule has been on TIs that if you go into a space and you touch less than 50% of the lighting in that space, you don't have to bring that space up to code. Right? The new number for TIs, anybody know? Anybody want to guess? 10%. If you touch 10% of the lights in a room, you have to bring that entire room up to all the interior lighting control requirements with a couple of understandings. So here's the table. If you touch less than, so here's the room, 1, 2, 3, 4, 5, 6. I can do my math right. That's, well, that one's off. So it's 18 lights. So if I touch 2 fixtures in this room, I have to bring this whole room up to the new code requirements. I go through and I figure out what am I allowed to use. So let's say for a classroom, and I'm not sure, but let's say it's 1 watt per square foot. Okay? So I have to then figure out, well, based on what I'm going to do the lights in this room, am I going to be at 85% or less than what that I'm allowed to use? So if I'm under 0.85 in this case, in this example, it says, oh, okay, so here you only have to follow 130.1a, which I wrote down here to remind everybody. I'm sure you all memorized it, but you got to have a switch in the space, not too bad, and you've got to have an automatic shutoff. You've got to have an occupancy sensor. For other things about multi-level, you can go with either 2-level or you can follow the multi-level requirement that might require you to put dimming in. So they're saying if you're really efficient, we'll let you actually just do 2-level and you don't have to worry about the dimming. If you, however, touch the space and based on what you did doesn't make it super efficient, doesn't make it less than 85% of what the area approach allows you to use, they say here we got the area approach, the area device, the switch in the space, we've got the shutoff, and we've got daylighting as a requirement now for any fixtures in the daylit zone. So I touch these 2 fixtures, I got to put daylighting in for the daylighting fixtures. And here I have to do the multi-level requirement, which means I might, if I don't make it super efficient, have to put dimming now. So I touch 2 fixtures and I have to put controls in and I have to put dimming controls in for this whole space. If for a school, I'm above 0.7 watts per square foot.
So what do you mean by touching the fixtures?
That's an excellent question. So let's take a look at what they talk about. TIs, okay? Where an existing lighting system is modified, luminaires are replaced, or luminaires are disconnected from the circuit, removed, and reinstalled, whether in the same location or elsewhere. Okay? This really has, this for somebody was a real heart attack because they were going, well, hold it, we've got jobs where we may do the HVAC system in the space. So what we'll do is we'll get the electrician in, they'll take all the fixtures out, they'll put them in a pile, we take down the ceiling, we go and we work on the HVAC system, then we put the same ceiling back up and we put the same fixtures back up. That certainly sounds a lot like luminaires are disconnected from the circuit, removed, and reinstalled. Ballast modification in place, replacing lamps and ballasts with the type or quantity. So if I'm just doing a lamp change out, that's what this is. There's also the optical system of the luminaire, replacement of whole luminaires 1-for-1 in which the only electrical modification is disconnecting the existing and reconnecting. So I've got a bad fixture. I'm going to just take that one down and I'm going to put a new one up. That's what this is. This then becomes a luminaire modification in place. And by the way, if you do those luminaire modifications in place, the rule is 40. If you do 40 fixtures or more, you have to start doing the same thing we were talking about before and bring the space up to code. Now, this one I don't know about. This is one of those, I think this is a wing and a prayer. Why? Because there's a lot of ballast type replacements, lamp replacements, all those things that never go out for a permit. Right? This one, though, TIs, those are permitted, right? Somebody's stamping it. This is going to be a big deal for folks to make a determination of whether or not what they're going to do. So know that they're moving the goal line. They're trying to figure out ways to reach into those old buildings, those existing buildings, and squeeze the energy out of those. And this is the method they're going to do it with. So commissioning requirements. If you've gone through a LEED project, you've seen what the commissioning requirements are for the LEED project. All that same kind of commissioning stuff is now part of the energy code. So meeting with the owner to figure out what the space is supposed to do, what the design's going to be like. Design phase review is kind of interesting, then a commissioning plan, and then documentation training and make sure you get a report, right? Well, this one here is going to surprise a lot of engineers, design phase review. So let me focus on this. Design phase review now is specifically, if I'm doing a job that's less than 10,000 square feet, me, my little firm, I can sign off on it on my own. If it's 10,000 to 50,000 square feet, I got to get somebody else in my firm to sign off on my lighting control design because they've got to make sure that it meets all the California requirements. If it's 50,000 square feet or greater, your design firm has got to go to an outside design firm to do a lighting control and lighting design review to make sure you're meeting the California requirements. This is different. This is pretty significant. And this nobody knows about. This is one of these things that's hidden there in the commissioning guidelines that people go, oh, they're not really going to make that. I'm hearing that this is definitely, that part of the reason those forms are so, have jumped over the last revision is because of making sure there's forms for every one of these steps for the commissioning process. And then lastly, I'll just touch on one last kind of a thing, which is, I said I wasn't going to talk any HVAC. This is the HVAC section, but I just wanted to point out one thing. There is, even on the HVAC side of the story, there is this idea that says, oh, you know what, for certain specific rooms, multi-purpose rooms, classrooms greater than 750, conference rooms, convention, auditorium, and meeting centers greater than 750 square feet, you've got to have an occupancy sensor in those spaces. You already told you had to have one for the lighting, but now this is saying you have to have an occupancy sensor in those spaces to provide information and go to setback control. So we got a nice little thermostat there. If there's nobody in the room, we let the temperature go plus or minus 2. When there are people in the room, we go there and we try to tighten it down. So you could have 3 different occupancy sensors in a room where there was plug load required. If it's multi-purpose room greater than, so you could have one for the lighting, you could have one for the plug load, and you could have one for the HVAC. Smart systems, like what we offer, is the idea of being able to take that single sensor and have one device then that it talks to control the lighting, and another one that it talks to control the plug loads if it's required, and another one to just give a little simple contact closure to the HVAC folks. Or we can go full-blown and actually network the whole building together, and then back at the front end, these systems can talk to each other at a system-to-system level, feeding them information about what's the status of the occupancy sensor in this room that we're in right now. That's allowed as well. And that, I think, is really, they tried to make a run-in almost mandatory lighting control, full building network systems. There's enough stuff in here that it's really going to push us to do that. It's not just going to be simple little controls inside a room. Once you throw demand shed in there and being able to reduce, you're talking communication networks. And then when you leap into things like plug load and HVAC, you start really realizing that where the future lies is with these whole building systems, which I'm sure you guys are really, I can tell right now, you guys are really excited, just thinking, guys and gals, excited about all this stuff and how it's all going to work and go together, and it's just not a pretty picture. This is monumental. This is really revolutionary, and the rationale is they're going for that zero net energy by 2030, and you don't do it by the way we've been doing it, which is small incremental changes, little bit by little bit. They're looking for the big steps, and there were a lot of them in this presentation. So thank you all, everybody, for the opportunity to come in. Thank you.